guys, in this video I'm going to just go over a couple review examples that we've talked about so far in Module 7. So one of the things we talked about is how to solve proportions. So remember, anytime I see a fraction equal to a fraction, a strategy I can use is to cross multiply. So I'm going to do 4 times negative 3 and set it equal to the other diagonal being multiplied. So I have x minus 5 times x plus 3. Okay, and then, so that got rid of the fractions, which is really nice. And then I'm just going to go ahead and multiply. So I got negative 12 here. And then this is where I have to distribute twice, right? I'm taking x times both parts, and then I'm going to take negative 5 times both parts. So x times x is x squared. X times 3 is positive 3x. Now I have negative 5 times x, which is negative 5x. And negative 5 times positive 3 is negative 15. Remember, when I have a quadratic, so something with x squared involved, I want to set it equal to 0. So I'm going to add this 12 to the other side and combine some like terms. So I'm going to add 12, and the 3 and negative 5 I can combine. So here's what I have left. 0 is equal to x squared. 3x minus 5x is negative 2x. And then negative 15 plus 12 is negative 3. So I'm going to check and see if this factors. That's typically faster than using the quadratic formula, so I'm going to do that. So I'm looking for two numbers that multiply to be negative 3 that would add up to be negative 2. So numbers that multiply to be negative 3 would be 3 and 1, where one of those numbers is negative. So if I make the 3 negative and the 1 positive, so they multiply together to be negative 3, and they add together to be negative 2. That is my correct factors. So now remember, to solve, I'm going to set each factor equal to 0. So here's one factor, and here's the other factor. And I'm going to solve those independently. So I'm going to add 3. So I have x equals 3, and subtract 1 for this equation, and I get x equals negative 1. These are my solutions. X could be 3 or negative 1, and that would make this equation true. Okay. Determine the scale factor. Okay, so this one's a little bit hard to see, you guys, but this is a segment right here. So I'm actually going to connect these two, and then it grows to be here, right? I know this is the new one because of that prime notation. So I'm looking at the length right here. So you can see these increments. So here's 2, and each of these is going by 2. So half of that would be 1, right? So I have 2 plus 1 is 3. So this one has a length of 3. I want to know what did it increase to. So let's see. So here's 1, 3, 5, 7, 8. Is that right? Sorry, I didn't do that right. 1, 3, 5, 7. Yeah, I think that is right. 8. Okay, so I went from 3 to 8, right? So I want to know, what is the scale factor? So another way we can think about it is we took our original, we multiplied by our scale factor. I'm going to use the letter k just to represent that, okay? And it equaled 8. So we are going to just divide to figure out what k is. So k is 8/3. All right? Find the coordinates of g if g prime underwent a dilation of a scale factor by 1/4 and it was centered at the origin. So remember, if it's centered at the origin, it has this same relationship, that the ordered pair got multiplied by k. So one way we can think about that is x, y, right? That's my original g coordinate, got multiplied by 1/4. And so now it's equal to negative 8/4 after that multiplication. So something that's helpful for me, you guys, multiplying by a fraction, remember, is same as dividing by its reciprocal. So multiplying by 1/4 is the same as dividing by 4. So going this direction, they divided by 4. So if I want to go the opposite way, I would multiply by 4. Okay, so dividing by 4, go here, do the opposite to work backwards and find out what the preimage was. So negative 8 times 4 is negative 32. And 4 times 4 is positive 16. Okay, and then we can check it, right? Is 1/4 of this negative 8? Is 1/4 of this 4? That works out. So that is our preimage coordinates for G. Okay, here I have an example where I want to dilate using a center that's not 0, 0. So I can't just multiply the coordinates here. This is where I'm going to kind of use the distances. So I'm going to mark my center at 3, -2. So there's my center of dilation, okay? We're using a scale factor of 1/2. So that means my distances, I'm actually going to label these, you guys. I'm going to call these A, B, C. Okay, so I'm looking at my distance from my center to each vertice, and those are getting cut in half, okay? So I'm gonna do A. So to go to A, I went, let's see, left 3, 6, 7, left 7, and up 2. So those are being cut in half. So instead of left 7, I'm gonna go left 3.5. Instead of up 2, I'm gonna go up 1. So that is where my new A prime is. Now I'm gonna look at B. So let's see, B, I have to go left 3, 5, and then up 1, 2, 3, 4, 5. So 5 and 5. So I'm cutting both of those in half. So left 2.5 and up 2.5. So let's see, there's 1, 2.5 is going to put me in the middle of that box, and that is B prime. And then C, left 1 and up 1, 2, 3, 4. So I'm going to go left 1/2 and up 2. So I cut those distances in half, so I'm going to connect here. It should look proportionally, right, the same shape. It is just a smaller version. And remember, these should be in line. So C should be in line with C prime, B with B prime in the center, and A with A prime in that center. So those should line up. That's just kind of a good way to check yourself and make sure that you have graphed the dilation correctly. Okay, that's it for the review examples, guys. Thanks for watching.